All right, lesson 11.10, graphing functions. I'm going to do my best to explain to you what a function is. Does anybody here know what a function is? Is that something that word are you familiar with? It's a very algebra term, a function. Here's the deal. Let me explain to you how a function works, okay? Pay attention. Think of a function as a box. There's a slot that goes in the box, okay? And then there's a spot for things to come out of the box, okay? What goes in the box is the x. What comes out of the box is y. Just pay attention. What I shove into the box is x. What comes out of the box is y. Here's the way it works. Imagine this. Imagine that this is x plus 2. In this situation, the function is x plus 2, meaning whatever I shove in, x, whatever number I shove in there, which is x, what comes out? Y comes out. What will come out, though? Now that we have this in here, what's going to come out? If I shove in 5, that's x. What comes out? 7. Does that make sense? This function is x plus 2. So if I shove in a 5, right, a little coin, shove in a 5, boom, throw it in. What happens to the 5 when it goes in there? It goes, whatever it is, 5, and then what happens to it? Plus 2. What comes out is 7. That's the y. Are you all understanding that? Is that making sense? Okay, let's try this again. Let's just say this time I shove in the number -4. I shove in the -4 into the box. Don't say anything. Think. I shove in a -4 into the box. Joy, what comes out? Perfect. -2 comes out. Why? What happened? What happened when it was in the box? 2 was added to it. -4 plus 2 is -2. Very nice. Here's the deal. Here's the deal. That's what a function is. Okay, another thing you can say is this. When you do this, you have another word for this. Instead of x, is you can call this input. Like you input something into the function. And then what comes out would be called output, right? Output. Okay? Input in, output out. That's the whole deal. Okay? The one thing that you're going to do here, is when you do this, you're going to make a table. And it's called, your input is over here, and output is over here. Make sense? Here's the deal. I'm going to do something for you. I'm going to give you some inputs, and then I'm going to give you the output, and I want you to tell me what was the function. What actually happened to the numbers when they went in. Does that make sense? So I'm going to do this for you. Here we go. If the input was -1 and it came out 3, just watch. And then I put in a 2 and it came out 6. Then I put in a 10 and it came out 14. Then I put in a 100 and it came out to be 104. Tell me what this function is. What is going on in the box? Now here's the deal. Try and say it algebraically. What is the function? Okay, what is the function? Kendall?
X plus 4 equals y.
X plus 4, right. X plus 4 is the function, and you're right, it does equal y. This is x plus 4. Remember, what am I shoving in there, Jonathan? What letter am I shoving in? B? What am I shoving in? When I shove an input, what am I putting in? What letter is that? I already said that earlier. X, right? So then what's happening when I shove in, no matter what I put in, what's happening to it? Adding 4, right? So if I shove in an x, when it goes through the box, it's x plus 4. That's what's happening. I'm taking whatever I shoved in, and I'm adding 4 to it, and it comes out. And this is called the y, right? That's the output. Okay? Listen, this is not a difficult concept. Just because I'm saying things in a way that you've never heard it before, this is a concept that is very basic. I know you understand this. Do not get hung up on the fact that you've never seen this. So, When you were in first grade, you'd never seen multiplication before. Do you understand what I'm saying? Don't get hung up on the fact that you've never seen it. Just go with me. I'm going to give you another one. What goes in is X. What comes out is Y. Another thing you could call X is input. What else could I call Y? Output. Okay. This time I'm not going to write input and output. I'm going to write X and Y. Even though I could have written input and I could have written output, I'm just going to write X and Y this time. Does that make sense? Doesn't look exactly the same. Shouldn't bother you. You know that X is the input and Y is the output. Right? Here we go. If I shove in -5 and I get 10, and then I shove in 0 and I get 0, and I shove in 2 and I get -4, and then I shove in 100 and I get -200. What is the function? When I shove these things in, these are the inputs, right? I threw in the number -5 and 10 came out. I threw in a 0 came out. I threw in a 2, a -4 came out, and I threw in 100 and a -200 came out. What is going on inside the box? What is the function doing to my number? Does that make sense? What is it doing to my number? I only have one person that knows the answer. I just put your hand up. If you know the answer, you tell me. What is it doing? How could the 5 have become -10? What are some possibilities here for 5 turning into... Give me one possible answer. How could the 5 become how could the -5 become a 10? What is one possible solution? Don't you agree that a -5 becoming 10 could have been that I added 15? Yes. Does that make sense, Jonathan? That I could have added 15 there. That should make sense, right? Okay. If that was true, then it would be the same thing here. Oh, but is 0 plus 15 0? No. So then, is it possible that it's add 15? No. No. What's the other possible solution to this? What's another possibility for the -5 becoming 10? Jonathan? Multiply by?
2.
No. -5 times 2 would be -10. So that's not it. Joy, what could it be? No, -5 times -15 would be a positive 75. That's not what came out. When I put in a -5, a 10 came out. Right. What about -2? Is it dividing it? Is it adding it? Multiplying, right? What's going on is I shove in a -5 and I multiply by -2, became a 10. When I shove in a 0 and multiply it by -2, what's it turn into? It still stays 0. When I shove in a 2 and I multiply it by -2, what's it come out? -4. When I shove in a 100 and I multiply by -2, what comes out? Do you understand? So then what is the function here? What's the function? It's X times -2. How do I write that though? If I want to say X times -2, is that how you write it? In algebra, how do you write it? You would write this -2x. That is the function, is -2x. -2 times x. That's how you'd write it. Does that make sense? I'm going to do one more. You guys should get this. This is not a problem. If I put input and output, is that going to bother anybody? Okay. What if I put X and Y? Is that going to bother anybody? Do the same thing, right? I want everybody to write this down. Write down exactly what the function is. What is going on? Does everybody have it? Listen, this is what I'm going to do. I'm going to give you a little secret here, okay? I'm going to show you a little secret. And you'll learn this more as we take pre-algebra and as you take algebra. But here's the deal. The input was 24. Agreed? That's what we threw in. This whole side is what we're throwing into the machine. And this is what comes out of the machine. When I shoved in a 24 and a 12 came out, do you agree that there are two possibilities as to what could have happened if that was the first thing I did? I shove in a 24 and a 12 comes out. What are the two possible things that could have happened? Name both of the possible things that could have happened. It could have been divided by 2 or minus 12. It's one of those two. Do you agree? That's what happened. It's either divide by 2 or minus 12. Just by throwing in the first one, can we know which one it is? No. So then I look at the second one. So it's either divide by 2 or minus 12. That's the possibilities. With this one, when I threw in 100, if it was divide by 2, what would have come out? 50. Is that what came out? No, 88 came out. Well, what's the other possibility? Minus 12. Oh, minus 12, minus 12. And now I'm just going to go by to the next one and make sure that we're doing it right. What is negative 10 minus 22? Sorry, what is negative 10 minus 12? Negative 22, right? Shove in a negative 10, subtract 12, it becomes negative 22. We're still at minus 12. When I have a 1 and I shove it in, how does it become negative 11? Does that make sense? So then how would you write this? How would you write this? How would you write it, Morgan? No, negative 12x means negative 12 times x. There's no multiplication here, right? So then what would you do? It would be whatever x is, so x minus 12. It's x minus 12. And that should make some sense. It's x minus 12. Whatever x was, that's the number we throw in. Remember, x is input. X is what we put in. Whatever x is, what's going on with it? It's being subtracted by 12, and then it comes out as y. And that's where it actually, this is a pre-algebra concept. That's why Kendall was right. It's x minus 12 equals y. That's the output. The input is x. This is what's going on in there, and this is what comes out. Okay? Your assignment today is a lot easier than this. Okay, it's a lot easier than this right here. Here's the deal. This is what they do. They're going to give you a table, and they're going to call it input, output. They're going to have this negative 1, 1, and 3. That's all they do, too. That's kind of an easy one. Okay? And then they want to know if this is the function. If the function is output equals input times negative 2. If that's the function, that's what's inside the box, right? Is input times negative 2. How would we write that? Instead of input times negative 2, what would we say? Negative 2x, right? It's the same thing. It's the same thing. They're just using the words output and input. Should that bother you? Should that bother you? No. We know that input is x, output is y. We know that. So, input times negative 2. So then, what goes right here? You tell me. What goes right there? If it's input times negative 2, what's my answer, Michael? Input times negative 2. Isn't that what they're saying? It's input times negative 2. So whatever the input was, what was the input? Negative 1. What's negative 1? Input times negative 2. What is negative 1 times negative 2? What's a negative times a negative? Negative 1 times negative 2? 2. If the input is 1, what's the output? Morgan? -2. Because 1 input times -2, 1 times -2 is -2. If the input was 3, if I shove in a 3, what comes out, Caleb? -6. Because input times -2, x times -2, 3 times -2. Make sense?
Yeah.
Make sense? You understand this, you are going a long way towards understanding the basics of algebra for real. Okay, what about this one? You guys try one. Do 1A at the bottom of page 558. Do 1A. I'll write it up here too, but you're still going to do it. 1A at the bottom of page 558. So here, watch. When you get to algebra, when you even get to pre-algebra next year, we're not going to put this input-output stuff. What are we going to put? X and Y, right? X and Y. That's fine, whatever. And it's not going to be that. What's this going to say up here, guys? What's that going to say? Y equals X divided by 4. This right here, that red circle up there, next year is going to look like Y equals. That's exactly how it's going to look. Do you see that they're exactly the same? Output equals input divided by 4. Do you see how they're exactly the same? Anyway, output equals input divided by 4. So if that's true, that means that Y equals, and that's not what we're looking for, Y equals, what does Y equal? Input divided by 4. Input is 16. What is 16 divided by 4? Right? How many of you got that right? Next one, -24. If that's what I shove in, if that's the input, right? The output, Y, equals the input, -24 divided by 4. What is -24 divided by 4? -6. How many of you got that right? -6. Nah, the next one, 36. I shove in 36. Boom, I throw it in. It's output equals input divided by 4. Ooh, input divided by 4. Input 36. 36 divided by 4 is? Right? Does that make sense? This should be making perfect sense to you. Now here comes this is algebra. But what is the title of this lesson called? Graphing functions, okay? Graphing functions. What does it mean to graph something? Put it on the coordinate plane. Putting it on the coordinate plane. Remember what the coordinate plane is, right? Here's the deal. Let's do one. Once I have my graph, here we go. Let's do this. Say I've done my deal. I had my function and I've come up with my... Hold on. Do I need to put input output there or can I put X and Y? You agree? Same thing. Input output. Can you tell me what is the function here? What's the function? Are you all trying to figure this out? What's the function? Raise your hand when you have it. I'll wait till everybody's hand is up because you all should be able to do this. What's the function? People, what I mean by that is you have to ask yourself, what's going on? How is that -2? When I shove in the -2, a 4 comes out. There's only two possibilities here. There's only two possibilities. How did the -2 become a 4? What's the function? It's either adding 6. Do you agree that it's possible to go from -2 to 4 by adding 6? Is that possible?
Yes.
It could be +6. Or, what else could it be? How else could -2 become 4? Sladen? Or multiply by -2. One of those. When I do the next one, -1 to 2, is that adding 6? Is -1 plus 6 2? No. So we know it's not adding 6. Is it multiply by -2?
Yes.
Yes. Oh. Is 0 times -2 0? Yes. Is 1 times -2 -2? You see how? So what's the function, people? Multiply by -2. You would say y equals -2x. Okay, now that we have that, let's go back here. Let's go back here to this. Have you noticed something here? Watch this. What do those things create? They create what are called points or coordinates, right? Look here. Paying attention up here. There's a -2 and a 4 here. Isn't this x and this y, right? X and y. Isn't this point right here -1, 2? Isn't this point here 0, 0? Isn't this point here 1 and -2? Isn't this point here 2 and -4? Right? Can't you plot those on the graph somewhere? This first one, -2, 4. -2, 4 is right there. Agreed? The next one is -1, 2 is right there. Where is 0, 0? What's it called? What's 0, 0 called? What's 0, 0 called? The origin. 0, 0, the origin. The next one is 1, -2, and the next one is 2, -4. Guess what it creates? What is that thing? A line. It creates a line. Could I have shoved something in here? What if I had shoved the number 4 in here? What would come out? Think! What's the function? What's the function? What's the function? Times by -2. So if I shove in a 4, what comes out? Which means that if this thing really is accurate, you notice that that's formed a line. Won't this land on the line somewhere? Yes. Won't my new point land on the line? 4, -8 is right there. Does that land on the line? Yeah. Oh. Right? What if I shoved in 1,000,000? What would come out? -2 million. Why is that true? Because that's the function. Multiply by -2. If I shove in 1,000,000, -2 million comes out. Can I plot the point 1,000,000, -2 million? Absolutely. That paper would be humongous, but I could do it. Guess what's guaranteed to be true about that point? It would be on the line. Lines go forever. It would be on the line. Does that make sense? Okay. Okay. Something that you should know is those functions that are addition or subtraction, functions that are multiplication or division. Are you listening to me? Yeah. Functions that are addition and subtraction, functions that are multiplication and division will end up being, simple ones like this will end up being called, they're linear functions. What they're talking about here in this little section here, this is the very basics in lesson 11.10. They're linear functions. Why do you think they're called linear functions? What's linear mean? What's the root word in the word linear? Line, right? Linear, line. Linear functions always form a line. Okay? And that makes your life easy. That makes it easy for you to do things. You can play with it a lot. When you know that it's a line, you can play with it. Right? You can predict. You can do lots of stuff. Anyway. Because this is SAT week, I'm not going to give you homework to do. I am going to give you your homework right now, but don't do it tonight. You'll come back tomorrow during class and you'll work on it during class tomorrow. Does that make sense? We'll probably go over it a little bit tomorrow, maybe one time, and then I'll set you free to do your homework. So your homework is going to be